Thank you for clicking on that thumbnail. Welcome to this solution video of paper 51, summer 2022. Question number 1. Find the number of different arrangements of 8 letters in word deceived in which all 3 E's are together and all 2 D's are together. So whenever they say some specific parts are together, write them together. So E, and E, all 3 are together, make them a box. They're inside a box. Now, even if they change places with each other, still it will remain E. So no need to worry about what is inside, just think about the box. They also want D's to be together. Similarly, they can exchange their places, but there is no change in the order. So these 3 E's become one body now, these 2 D's become one, and other, how many? If there are 5, so 3 more will be left. Let me see, what are they? C, I, and V. So they are 1, 2, 3, 4, and 5. 5 different parts are now. They can change their places with each other. Whenever we say that 5 objects can change places with 5 of them, then we write 5 factorial as their arrangement. And that's the answer here, 120. We don't have to worry about what is inside the boxes, straightforward. Find the number of different arrangements of letters, 8 letters in the word deceived in which the 3 E's are not all together. This word all is very important. That means 2 E's can be together, but not all 3 E's, right? So let's take a situation when all E's are together. Okay, so if all E's are together, again make a box around them, and they can interchange places with each other without affecting the order. So this is one body, and then we have 2 D's, and then we have C, I, V. How many are they now? 1, 2, 3, 4, 5, 6. They can be arranged 6 factorial ways, but there are 2 D's somewhere, maybe here and here, right? And if they interchange their places, even then the order will remain same. So we have to divide it by 2 factorial. This is the arrangement if all E's are together. But the question is that all E's are not together. So we'll subtract this situation from total number of arrangements. What are total number of arrangements? They are 8, so 8 factorial. Just like these 2 factorial, we'll write 2 factorial for D's and 3 factorial for E's in total, right? So from this, we'll subtract this 6 factorial divided by 2 factorial. Just put this in a calculator and you'll get it. What I get is 3000 arrangements. Question number 2 is also about permutation and combination. There are 6 men and 8 women. Okay, so men are 6, women are 8. All right. The committee of club consists of 5 of its members. So there are total 14, right? Out of that, 5 will be in a committee. Mr. Lan and Mrs. Lan are members of committee, members of the club, not committee, club. That means they are among these 14. Okay. In how many different ways can committee be selected if exactly one of Mr. Lan and Mrs. Lan? That means exactly, either Mr. Lan has to be there or Mrs. Lan has to be there in the committee. So let's talk about Mr. Lan. So Mr. Lan is in the committee, so 100% chances of him being selected. Now remaining are how many people? 13? No, 12. Why 12? Because Mr. Lan is already in and we don't want Mrs. Lan to be in committee. So these 2 will not be part of next selection. Out of those, we have to select 4 people, isn't it? Because 1 is already occupied by Mr. Lan. So this is the answer. Similarly, Mrs. Lan, exactly same situation. She is selected and we have to select 4 out of the rest. And just add this, or you can write 2 times 12C4. These are the number of selections, total 990. Okay. In how many different ways can the committee be selected if Mrs. Land must be on the committee and there must be one more woman than men in the committee? So men were 6, women were 8. Now we want men and women. Mrs. Land has taken this place, so we want more women. So let's say that there are 0 men. So how many more women we need? We need 4 more women, right? To make committee of 5. Now one man is there. Mrs. Land is already there. We need how many? 1 plus 1, 2 plus 3. Now there are 2 men. Mrs. Land is already there, plus 2. Number of women are 5 here, 4 here, 3 here, still more than this. But if I do 3 here and Mrs. Land is there, then I need only 1 woman. That makes woman 2 less than men. So this is not acceptable. That means these are the 3 situations only. Now, since we have to select 0 men out of 6, we can write 6 0. Though it is 1, let's write it. So this one becomes 6 0 and we need 4 women out of 4. Sorry, 8, not 8, 7. Because Madam Lynn is already there. So we'll have 7 women available, from where we have to select 4 women. Similarly here we need 1 man and 3 women from 7. Then we have selection of 2 men and selection of 2 women, right? We are not selecting Mrs. Land because she's already there. It's confirmed. So either this will happen or this will happen or this will happen. So we'll add these 3 cases. Okay, so you can very carefully put this in a calculator and I get 560 when we do this. All right. Question number 3. They have given a table here. Okay, it's in increasing order. Frequency is also given, and they are saying that draw a histogram for this. So we can do what? Let's put it here and make it a little bigger so that it is easier to draw. For drawing, first we need to know the frequency density, because can you see here the difference between 0 and 20 is 20, 20 to 30 is 10, 30 to 40 is 10, then again 20 and 30. That means they're uneven groups, so we cannot compare the frequencies. So what we can compare is frequency density. 440 divided by 20 is 22. This is frequency density for this column. 720 divided by 10 is 72. 920 divided by 10 is 92. And 300 divided by 20 is just 15. 120 divided by 30 is 4. That means the lowest frequency we have is 4. Highest density frequency we have is 92. That means we have to select our frequency density from 0 to about 100. I will do that. And here we need up to 90. Let me do that. Okay, so I have the scale now. Now we will from 0 to 20, from 0 here till 20 here, we will draw a column with 22 frequency density. So 22 is somewhere here, so this becomes frequency density. So this will be the height. Okay, next is 72, 72 from 20 to 30. And this is how I will continue this. So now we will just draw the vertical. Okay, so I have drawn them somehow and with different colors. You can see that this is frequency density and this is time taken. This is the histogram. All right. What is the next part? From data, The estimate of mean value t is 3144. Okay, calculate the estimate of the standard deviation of the times taken to travel to the college. Okay, we have to find the standard deviation. Standard deviation formula will be sigma x minus x bar square over n. X bar here is the estimated mean 31.44. They have already that, so there is no need to find the mean. They have saved our time. So what we have to do, every x value, what is x value? We should know what is x value. In this case, 0 to 20, x value will be the middle of 0 and 20. Add to 2, 0 plus 20 is 10. So that becomes x. So 10 plus 30 is 50, 25. 30 plus 40 is 70, divided by 2, 35. So mid value is the x. So here it will be 75. So we got our x's. Each x, we will subtract 31.4 from each x and square it. So let's do this part first, and then we'll divide by total number of data. They have given us 2500. So denominator is known to us, 2500. So we'll do here sigma x minus, that means 10 minus 31.4, which is minus 21.44 square, plus 25 minus 31.44 will be minus 6.44. Then we have 35 minus 31.44, which will be 3.56, not 36, 56 square, plus 50 minus 31.44. We are, this x prime is 31.44, okay, which they have given. We are subtracting from each one. So it will be 18.56 square. I'm adding them because there is a sigma. Next, we have 75 minus 31.44, which will be 43.56 square. Carefully, sigma, I should not write sigma here because I'm already adding them. So just squared and divide by 2500 and you will get your answer. What I'm getting here is 15.16, which can be rounded off to 15.2 minutes. Okay, next. In which class interval does the upper quartile lie? Okay, so this is the one. Upper quartile, Q3. Upper quartile is also called Q3. For Q3, we should know 3/4 of total number of data, and we have 3/4 of how much? 2500, which is 1875. Now we should go back to our table and see where are we reaching at 1875. That was 1875, right? 1875 is 3/4. So let's see where are we reaching at 1875. 440 in cumulative frequency. 440 remains 440. Now I include 440 and 720. 1160 will become the total of the two. That means we have not reached at 1875 yet. 920 will be added to this. So 900 will make it 2080. 2080, and yes, 1875 is somewhere in this particular column. So it is 30 to 40, right? The question is, in which class interval does the upper quartile lie? In which quartile, in other words, is 1875th data lie? And we just got it. It is from 30 to 40. This interval. Okay. What is next? It was later discovered that the times taken to travel to college by two students was incorrectly recorded. Okay. one student's time was recorded as 15 instead of 5. Okay, 15 instead of 5. That originally it was 5 but written 15, and others recorded 65 instead of 75. It was 75 but recorded 65. Without doing any further calculation, state with the reason whether the estimate of the standard deviation in part B would be increase, decrease, or stay the same. So let's see. Originally it was 5 written 15. Okay, 5 and 15 both are in same interval. That means this 22 will not change, this 440 will not change, nothing will change, and even 21.44 will not change. Other was 75 but we wrote 65. Again 65 and 75 are both in same interval. This is not going to change anything. So yeah, both of them are still the same, still in the same interval, so nothing will change. So let's write here, since 5 and 15 and 65 and 75 both belong to same interval, there won't be any effect on standard deviation. Okay, because we used mid value of limits, so it is not going to change anything. Okay, next question is this: Jacob has 4 coins. One of the coins is biased such that when it is thrown, the probability of obtaining the head is 7/10. So let me try to draw a tree diagram here. So head, the probability is 7/10. That means tail will be 3/10. Okay. The other 3 coins are fair. Okay, we can't draw 3 of them. So let's draw one of them representative of these. Okay. So they are fair coins. That means probability of head is half. Probability of tail is also half. Okay. Jacob throws all 4 coins. This one and these 3. 4 total. The number of heads that he obtains is denoted by the random variable x. The probability distribution is this. Show that A is 1/5. That means probability of receiving one head is 1/5. So suppose the first one is head. This one first, I'm calling this coin number 1. These are coin number 2, 3, and 4. Okay. The first one gives us head, but we want exactly one head, right? So head, that means all of them have to be tail. So let's write the probability of this one. Probability of head is 7/10 times probability of tail in each one of them will be half. It's a fair coin. So it will be how much? 7 divided by 80. Now, if the first coin is tail, the probability is 3/10, right? That means we need one head in any one of these 3, right? Either this can be head, or this can be head, or this can be head. We can write 3C1. Out of 3, any one has to be head. And what is the probability of head? Not probability of head. Probability of this combination will be half times half times half, isn't it? Because probability of first head will be half, this tail will be half, this tail will be half, and because of 3C1 we are changing the position of head where it is. So what do we get here? 3/10 multiplied by 3 multiplied by 1/8, right? 3C1 is 3. So 9/80. So either this will happen, we'll get one head because of this, or this combination will happen, we'll get one head out of that. So probability of exactly, rather in place of exactly one head, let's write x equal to 1, because they are using probability of x equal to x, no? So x equal to 1, which will be 7 over 80, this one, or 9 over 80, this one, which is 16. 80, and if we cancel, we get what they want, 1/5. They said show that a is 1/5, and we got 1/5. All right. What is next? Find the values of B and C also. So we'll do the same thing for B and C. In B, we have two heads. So first coin is head, and first coin is tail. There are two options, right? So let's talk about this. How can we get two heads from this? That means we need, again, similar situation here, like I had, not here, not this one, this one. One head out of 3. So H, T, T, exactly same thing will be right, 3C1. So let's write same again. Head, probability of head is 7/10. Then 3C1 times 1/8. This is what we got, and that came out to be how much? 9/8. Yeah, no, not 9/8. 7 times 3, 21 over 80. 21 over 80. This was 3/10 here, and this is 7/10, so it will be different. So 21 over 80. Second case. First, the biased coin has tail. That means we need two heads and one tail from here. Then only we can have exactly two heads, because this is confirmed tail. So confirmed tail means 3/10. And here in place of head, I will say that I want to use the exactly same, because only one tail is there, and that tail should have some position. So I'll write the same thing again. In place of head, tail is 1, so I'm focusing on it. So how much that will be? 3 times 3 divided by 89. 9 over 80. So add these two, it becomes how much? 21 plus 9, 30 over 80. So 0 and 0 cancel. 3/8 is the value of B. 3/8. This is 1/5. Okay. Now, next possibility. All three are heads. Yeah, there are three heads. So the first one is head. First one is tail. Two situations. That means from the remaining three, two must be heads, isn't it? Head, head, and tail. In this combination, we'll have three heads. So first, this position, this head has a probability of 7/10. And again, I will use for tail, not for head. It will make it easy. 3C1 times 1/8. So 7 times 3, 21 over 80. 21 over 80. All right, tail. So first one is tail. That means all three heads must be from the remaining three, because we can't get a head here. We have confirmed that first one is tail. All three will be heads here. So first one is 3/10, and there is no 3C1 now, because we are confirmed all are heads. So 1 over 8 only. So it is how much? 3 over 80. Now add these two. We get how much? 21 plus 3, 24 over 80. And we can divide by 8. 3, 10. 3 over 10 is the probability of getting exactly 3 heads. We have completed the table. We have showed A and B and C. We found the values. Okay, what is the next question? Next question says find EX, expected value of X. So for expected value of X, we should have sigma X and P, probability of that X. Okay, sigma means we'll have to add them. So 0 is X and its probability is 3 over 80. So 0 times 3 over 80. Sigma, because of sigma, plus 1 times we got 1/5. Yeah. 2 times, what is the probability of 2? 3/8. Plus 3 times 3/10, and 4 they have given 7/80th. So Let's write there LCM 80. Okay, this already, oh, this is 0, so no need to look at this. 5 times 16 is 80, so 16 will be multiplied with the numerator. 16 times 1 times 1 is 16. 8 times 10 is 80, that means 10 will be multiplied with 2 times 3 is 6. 10 times 6, 60. 10 times 8 is 80, that means 3 times 3 times 8. 9 times 8, 72. 80 is there, so 4 times 7, 28, no need to multiply with anything. So 28 plus 72 is 160, 176. 176 over 80. And if we want to express this in decimals, we'll get 2.2. That is the expected value. Okay. Next one. Jacob throws 4 coins together 10 times. Okay. Find the probability that he obtains exactly one head on fewer than 3 occasions. So we have to find the probability that x is fewer than 3 and x is not that x. X is the success that we get one head, exactly one head. What was the probability? 1/5. Look at here. Exactly one head is 1/5. That is the probability of success. So probability of success, which we write as P, is 0.2. 1/5 is written as 0.2. You can write 1/5 if you want. And so, the probability of failure, Q, will be 1 minus 0.2, which is 0.8. So we want this success, x is number of successes. So we want less than 3, which we can write as probability that x is equal to 0 or probability x is equal to 1 or probability x equal to 2. One of these 3 things will happen, and we are using OR. When we use OR, probabilities are added. So let's write what is the probability of 0. So we'll use binomial distribution in this because 0 can be any one of the 10 attempts. So 10 C0 success to the power 0 and failure, all 10 are failure, plus 10 C1 0.2 to the power 1, 0.8 to the power 9, plus 10 C2 0.2 to the power 2, 0.8 to the power 8. Keep in mind, 1 plus 9 is 10, 2 plus 8 is 10, 0 plus 10 is 10. Their sum should be 10 because there are 10 attempts. Alright, so carefully put this in the calculator and you'll get your answer. What I'm getting here is 0.107374. Okay, 0.2684348, 435 you can write, plus 0.301989. So we did not go to 3 because there is no equal mark here. They're saying fewer than 3. That means 3 is not part of it. We get 0.6783 significant figures. Alright. What is next? Find the probability that Jacob obtains exactly one head for the first time on the 7th or 8th. Again, they have written or. That means this is first time, right? They think first time. That means before 7 attempts or 8 attempts, it's failing. So it becomes geometric distribution, probability distribution. In geometric probability distribution, let's say Px equal to 7 or probability x is equal to 8. In geometric progression, 6 are failures in this case. So probability of failure was 0.8. Exactly 4 coins. And what is the score? 1 head. Yeah, correct. So 0.8 2 to the power, rather we are failing now, we are failing 6 times. So 0.8 to the power 6 multiplied by 0.2. In this case, we are failing 7 times, and then we are succeeding. Both of them have 0.2. Let's take it common. Both of them also have 0.8 to the power 6. So this one whole thing has taken common. So 1 plus here 0.8 is extra. Alright, so it becomes 0.2 multiplied by 0.8 multiplied by 1.8. Okay, what I get is 0.09437 and more digits, but we can round it off. 0.0944. Okay, next one. The length in centimeter of the leaves of a particular type are modeled by the distribution, normal distribution. Okay, they have given mean and they have given everything else. Okay, what you need to do, find the probability that the randomly chosen leaf of this type has a length less than 6 centimeter. So let's try to visualize this. So this is normal distribution, mean is 5.2, standard deviation is 1.5. This is variance they have given, we are writing standard deviation. We want this time less than 6 centimeters. So 6 is here and they have made our job easy. Less than 6 we want. So if you use the table, normal distribution table, it will be very easy because that table is about being less. So first let's find Z score for this, right? So Z score for X less than 6 will be X itself minus mean over standard deviation. What do we get here? It comes out to be 0.533. Okay, 0.533 is this. 0.5 is here, 0.53, 0.7019 and 3 more, 10. So we have to use 10 to last 2 digits of this, 0.7029. This is what we get now. So 0 point probability that X is less than 6 will be the probability connected to this Z score, which was 0.7029, and we can round it off to 0.703. This is the probability that the leaf will be 6 centimeter or shorter. Okay, length of the leaves of another type are also modeled by a normal distribution. A scientist measures the lengths of a random sample of 500 leaves of this type and finds that 46 are less than 3 centimeter, 95 are more than 8 centimeter long. Okay, find the estimates of mean and standard deviation. Okay, so they have not given any probability, mean or standard deviation, but they have given this information. So this is an experimental probability. So let's find what is the probability that X is less than 3. Is 46 out of 500. Can we convert it to decimal places? So 46 out of 500 will be 0.092. Probability that X is greater than 95. No, 8 centimeter greater than 8 is 95 over 500. 0.19. So we know the probabilities now. So let's try to visualize them also. We don't know the mean. Let's call it mu. Okay, but we know that if it is less than 3, probability is 9.2%. We know that less than mean is 50%. That means 9.2 is very, very small. It is somewhere here. So 3 centimeter long leaf will be here, and we know this is the area below this. Now they're saying more than 8 centimeters is 0.19, 19%. So it will be a little bigger, but here. And these two situations will help us to find mu and standard deviation. Okay. So what do we need to do? We have to find Z score from P like we did earlier. From Z we found P. From here we'll go back to our table and see what is the P corresponding to not 0.9. Okay, this will be a negative Z score. We know this, right? Negative. So we have to do the opposite of it. So subtract 0.092 from 1. So we'll get the positive counterpart of 3 somewhere here, and then we'll find Z score and we'll put a negative in front of that Z score. That's how we will find the Z score for this. Let me repeat. Because the table I'm going to show you, some calculators do this, then it's okay. But the table I'm going to show you will be having only positive Z score, not negative, which anything less than mean has a negative Z score. If I don't get it here, so what do? I reflect it on the other side and find the Z score of its counterpart. And find the Z score, the probability should be less than. And this one will be reflected to more than. So that's why I'm subtracting from 1. 1 minus 0.092 will be how much? 0.908. Yeah, 0.908. So let's look at 0.908. So 0.908 will be here. Can you see here 0.9066 here? We need 14 more to make it 0.908. So 14 will be given by 9 here. So 1.329. 1.329 is the Z score for this. For Z, we had probability earlier. So Zx is less than 3 is minus, because I told you if we get a positive, we'll make it minus 1.329. Got it? Similar thing we'll do for 8. It is more than, and the table I showed you is always for less than. So what will we do? We will find the probability which is less than this. If this is 0.19, yeah, this is what we got. The less than will be 1 minus 0.19, which is 0.81. So this probability will convert to Z score just like this. So we'll look at the probability 0.81. Okay, 0.81. Yeah, 0.8078. Can you see here? 0.8078. We need how many? 22 more. So do we have 22 somewhere? Yes, we have. So 0.878, 22 is here. So what do we get? This is 0.878. 878. So that's what is the Z score for X is less than 8. 0.878. So we got Z score for both. Now we can find mean and standard deviation as they are asking us. Standard deviation and mean. So the equation is that Z score is X minus mean over standard deviation. That's what we used here in the previous part. If you can see here, Z score here is minus 1.329. You can see here, equal to X was 3. Yeah, and minus mu is unknown and sigma is also unknown. So let's cross multiply this here. What do we get? Minus 1.329 sigma is equal to 3 minus mu. Mu goes to the left side, equal to, and this can come here, 3 plus 1.329 sigma. Got the first equation. Let's find the second one. the Z score is 0.878, will be equal to X, which is 8 in this case, minus mu over sigma cross multiply 0.878 sigma is equal to 8 minus mu. Mu comes to left. So it becomes 8 minus 0.878 sigma. Now we have mu equal to something here, mu equal to something here. That means this part can be equated to this one. Let's write it here. 3 plus 1.329 sigma. Let's exchange the places of these two. So we get what? 8 minus 3 equal to 1.329 sigma plus 0.878 sigma 5 is equal to 2.207 sigma, and that's how sigma comes out to be 5 divided by 2.207, and that is almost 2.2655 rounded off 2.27. Yeah, this is sigma. So mu can be found from anyone. Let's use one of these. Let me use this one, this. So mean is equal to 3 plus 1.329 sigma is known to us now, 2.27, right? So mean will be 6.01 approximately. Got both of them. All right, proceeding. Next question is this. In a random sample of 2000 leaves of this second type, okay, the second part we did, how many would the scientists expect to find within, how many, not probability, okay, how many, then total numbers, within the lengths more than one standard deviation from the mean. Okay, so this is mean. We found mean how much? 6.01. We want one standard deviation on this side and one standard deviation on this side. So we'll find, we know the Z scores. Yes, we do. This is 1 and this is -1. They have said one standard deviation away from the mean. And what is the measurement of being away from mean? Z score. So this is one Z score, this is -1. So now we can look at the probability for Z score 1. -1 will not be there, but we will use the same thing. 1, 8413. Can you see? 0.8413 is the area, this one, less than 1. But they are saying more than, if you look here and look at the question carefully, they're more than one standard deviation away. This part is closer. So basically they are not asking this, they're asking the one which is away. That means this one they're asking. Since we know now this is 0.8413, yeah, 0.8413, this one is 0.84, so this one will be 1 minus 0.8413, which is more than, and that will be how much? 0.1587, correct? Now since this is -1 here, this area will be exact replica of what we found here. So we will add the two, means we'll multiply 0.1587 two times, because we want these two areas which are more than one standard deviation away from the mean. So both are exactly same. Just double this, we get our answer, which is 0.3174. and if you want to round off, you can write, okay, let's not round because they're saying how many, they didn't say probability, right? How many? So we have a sample of 2000, So 2000 multiplied by 0.3174 will be the number given to us, which we are getting is 634.8, which we can round off to 635 because we can't have a point leave. So we have answered 634 or 635, but since it is closer, we are estimating, right? We are estimating, we are not writing it the proper way. So 635 leaves is the answer for this one. Question number 6. Janice is playing a computer game. She has to complete level 1 and level 2 to finish the game. She is allowed at most 2 attempts at any level. 2 attempts. Okay. Level 1, the probability that Janice completes it at the very first attempt is 0.6. Alright. So this is the first one, and 0.6 is the probability, and this is 0.4. That means she fails. She does not win. So win, lose. Okay. Then if she fails, now this one, if she has won, she'll go to the second level. But if she fails, she will again try it, and she completes it. Second attempt, 0.3 is the probability of winning. 0.7 will be losing, right? If Janice completes level 1, she immediately goes to level 2. That means this finishes here. From level 2, for level 2, the probability that Janice completes it at the first attempt is 0.4. That means 0.6 she does not. If she fails her first attempt, the probability that she completes the second is 0.2. So 0.8 will be that she will lose that attempt. Alright. So this has been picturized here. Show that the probability that Janice moves to level 2 is 0.72. Level 2. So she can move from second level through this way. So this is the probability that she will move. So 0.6 is the one probability. Second is she fails first but then moves. 0.4 times 0.3. These are the two ways she can go to level 2, and which will be 0.6 plus 0.12, which is 0.72. Alright. Second one, find the probability that Janice finishes the game. Okay, so let's see how can she finish the game. She wins, goes to the level 2 through this, then wins the second one also. This is one possibility. So 0.6 multiplied by 0.4, and if she finishes, or she finishes first one but loses the second one and then finishes. So 0.6 times 0.6 times 0.2. Third option, she loses the first one. She does not go to level 2 first, but then she goes, right? Then she wins the second level straight away. So what is that? 0.4 times 0.3 times 0.4. And finally, she loses first game in both attempts. So this. So it comes out as 0.4 times 0.3 times 0.6, 0.2. These are the 4 ways she will finish the game. So it will be how much? 0.24, 36, 72, 0.072, 0.048. Please, you can use calculator. I am using mental math. I'm used to it, so please do not do that yourself. You can use your calculator. Okay, so if I add all of these, I get 0.3744. You can round it off to 374. All right. What is next? The last one. Find the probability that Janice fails exactly one attempt given that she finishes the game. Okay. So let's do this way. Fails exactly one attempt. Let's name this event as A. She finishes the game. Let's give it the name event B. And we know that probability that A given B is P A intersection B divided by PB. So PV we already know. In this we got it. Let's use 3744, right? Now we have to see out of these four events, these four, she fails exactly one attempt. Let's look at this. These are both wins. So no, this was not the one. She wins the first one, loses the second one, and then wins. Fails exactly one. So she failed once. Yes, this is the one. So this A will be 0.6 times 0.6 times 0.2. This will be one of them. Or she loses, then she wins, and then she wins. Again here, this is also the one. 0.4 times 0.3 times 0.4. And here she loses, wins, loses, wins. She does not lose exactly once. So these are the only two. And divide by PB. 0.3744. Okay, let's calculate this with a calculator and we'll get our answer. 0.72 plus 0.048 divided by 0.3744, which is 0.120 divided by 744 equal to 0.3205 rounded off to 0.321. This concludes our exam 51 of summer 2022. Thank you for watching. If you like this video, please share with your friends and please subscribe to this channel. I will make many more videos in coming days. Thank you very much.